Let's do. uh, Let's try our best to finish chapter one today itself. Like, let's finish it. Because no, I mean, here nobody cares what I'm doing. So why do I need that, right? Yeah, let's do all of chapter one. How many? There are like 12 chapters. You have to finish one chapter in one day. All right. Um. Actually, first of all, I have one question. I know I don't need all the chapters. That is for sure. I don't need all the chapters. What chapters are core from these images? Oh, okay. This is okay. Wait. Um, I don't know what is going on with OpenAI today. I swear it is pretty stupid nowadays. Is it this one? Nope. Yes. Here, this. These are. These are. Oh, okay. Mm. It's not able to understand what's going on. It's this. These all chapters. So all the chapters are important. So all chapters are important. Okay, one, two, and three. So absolute foundation and system execution, performance plus hardware, language plus runtime engineering. Oh shit! What's going on? Let's finish one, two, and three. We'll try. Yeah, I mean, we have to try our best. We have to try our best because there's the ASCII codes and how the computer reads and all that stuff. So you need ASCII language. I don't know if they are able to even read it. Oh yeah, definitely have to study because you know what my plan is that when time comes where people will ask, okay, explain the book. Yes, I'm using um what ChatGPT right now. Definitely I'm using ChatGPT. You know what? Actually, let me. Yeah, I am definitely using ChatGPT. Definitely I'm using ChatGPT. But like, when time comes where people will ask, okay, we have a lot. Okay, that's a lot. All right, let's go one image at a time, step by step. Let's go one image. Explain thoroughly what is going on. Thoroughly, good explanation, make it understandable. Please, please, please. And yeah, make it understandable. Okay, wait, nothing's clear. Nothing is clear. W- Um, what's going on? Like you explained everything in one go. Everything in one go. What is going on? One step, let me understand, and then next step. You explained everything. This guy explained everything in one go. Okay, so what happens is if I have print f as hello, and then you're gonna read it, but the computer doesn't run. Obviously, it's gonna read zeros and ones. So inside the CPU there is no hello printf or text. So it's gonna read at 0 and 1. Yeah, I already know that. Okay, you know what? By the time actually updated. Um, so it's gonna read. Okay, so long story short, it reads in zeros and ones. Correct? Yes, I know. Yes, I know. Um, Actually, explain using an example. I am using it for my Joblin notes. I can't use iPad at the moment. The computer converts A to ASCII table to 65, so internally A is 65. So 65 is going to convert to binary, and the memory will store 0, 1, all the zeros and 1, so not the letter A. And so when displayed to the screen, computer will read that, and then ASCII will tell me that this is A. And so the entire pipeline is at A, 65, that memory. So suppose malware changes 0, 1, 0, 0, 0, 1 to that, and now it'll be 66. So from 65, it's going to be 66. So the output will change from A to B by only changing the bit. All right. Got it. Book one notes. Now, don't just I'm writing a book here. So good examples would be nice. So A is 97, P is 112, I is 105, dot is 6. So 97, 112, 105, 46. So each of them converts to binary. Then obviously it's going to read in numbers. Yeah. All right. Got it. So A converts to. So how computer reads. So how computer reads the letter input by the user. I'm going to take my time. I don't care. I will take my time. Step two, step three. I already know them. That's why. Step four. And there you go. Right. So that's what it reads. All right. This page now. Oh, there's ASCII representations. All right. This page now. Go. Explain nicely, thoroughly, with explanations. Yeah. And at the same time, while you explain and give examples, let's also use latex code for the book. I don't think he understood, but there's nothing you can do, right? Nope, that's not the first page. Okay, it's not able to read actually. Hmm. Ooh. No, I meant this page here. So it's okay. It's not actually able to understand which page I gave. So I gave this page here, this page, this page, this page, this page. Yeah, it doesn't. It's not able to understand. Yeah, I told you it didn't understand. So a hello program begins as a source program, so meaning you create hello.c. So you created the C file and then you created the file name hello.c using an editor. For example, that's the example to you, and but it looks like text, but to the computer this becomes numbers. So the computer will store them as bytes, and a byte is 8 bits. Each bit is 0 or 1, right? And the table will show that includes to the stdio.h, it converts to ASCII integers, and it's going to convert all the other. Um, okay, okay, that's an ASCII. So you're going to have. Okay, wait. So that is hash is 35, 35 for 10, because in ASCII it is with 10 and the binary is with 2. So 1, 2, 4, 8, 16, 32. So 1, 2, 3, 3 and 32, 35. And then 105, so 35, 105, 110, and 99. Right? Yeah. Let's connect with cybersecurity. Come on. Oh, come on, man. Oh, come on. Let's let's yeah. It's not able to understand. You must understand this. Not able to understand. It's so how can the book be written? Yeah. Um. hmm, You know what? I already understood what's going on. Um. I can also read it. So hello.c, you saved it as a file, and then you write the code, and each of those let hashtag include third bracket stdio. These are all converted to values, right? So they have ASCII numbers and they have the binary. Those ASCII numbers converted to binary. You convert the ASCII numbers to binary, and each of the word is read in binary format, and then they're going to combine it into one, and there you go. Uh, you got your program, right? But yeah, they're gonna write a lot of words. So you write a lot of words. You write a lot of words, a lot of English, which actually overlaps with the main explanation. But I understood what I luckily I know what's going on. Luckily I know what's going on. Really. But in general, nobody will understand how you explained. Just giving you a heads up. I understood though. There you go. This is what you want. So machine is bits plus context. So if I have include stdio, then ASCII representation would be, let's say the value, the hashtag is 35, I is 105, N is 110. So each of them you're going to convert it to binary representation. And then the byte definition, one byte is 8 bits, bit is 0 and 1. And the character encoding function, E of C is equal to N, where C is the character, N is the ASCII integer, so E of A is 65. And the new line character, do we have a new line character here? Oh, yeah, we do have a new line character. So hash is what? Hash is what? Oh, hash n directly there is. Hash n is 10. You're going to have 104, 101, 108, 108, 111, 10, 119, 111, 114, 108, 110. Right? That's the explanation I want. See, it's really good now. All right. Um. Yeah. Can we use? Thing is, I don't want to get copyright. So can we use another example to explain the image? Explain the image, please. But yeah, I understood what's going on. Like the first byte has integer of 35, which converts to hash. So the main aspect, the main. Okay, so it's still good. All right. So what happens is that each of the whatever the code you write, they'll be each of them will have the ASCII code, and those ASCII codes will then be converted to binary values. Each of them will be converted to binary values, and then you're going to add those binary values. So you're going to have some binary value, some binary value, some binary value, some binary value, and the next some binary value, and so on and so forth, like that. But yeah, I understand what's going on. I understood what's going on. Yeah. So I can just um. So let's say that's scantarget.com. So let's say that's what you're going to do. So you're gonna okay. There is one. So this comes first, followed by this. Yes. So how does computer read an actual program, and how does it correlate to yeah, how does the computer read an actual program? There you go. And then these are converted to binary representations. So then they're converted. So first what happens is so we're just going to write that actually. It converts from that English hyperlink to ASCII code, this, and it converts to a binary representation. Next, it is converted to binary representation. It is then converted to a binary representation where 1 byte is 8 bit and 1 bit represents 0 or 1. 0 or 1. So that is typically written. So the scan is so S is what? So 1 1 you have 115 99. So 115 99 mm, 97 and 97. 115 99 97 97. So here now it converts. So in this case, can is converted from SCAN to each of those letters converted to ASCII. Right? Cool. Yeah, programs are translated by other programs in different forms. So now programs translated by other programs in different forms. The programs translated by other programs in different forms. Right, so what is going on here? Maybe use an example, like use a similar example. I don't want to get copyright strike because I'll be honest, like like using OpenAI, like you will get copyright strike because they're used to taking details, they're used to taking personal information, so they will unconsciously make you fall into this copyright thing, right? We have 9 chapters. All right, we'll try to finish 9 chapters. All right. Um, Using an example like how you explained just now, like step by step, like don't overlap. Just explain key stuff. Like don't use like storytelling English. This guy has. Okay, you know what? I'm just not going to talk too much. So explain um, core concepts. Core concepts do not overlap with random English. Just explain what is in the image. Just explain what is in the image and use a different example. Again, I have to remind him every time I am writing an academic book. So compilation system is that the goal is to have a human readable code and to an executable machine program. If I have scan.rs, the code will be fn main, then print target detected. Okay, what is going on? Hmm. What's this? Okay, so you said that source file, so scan.rs. Hmm. So you have a source file which says scan.rs, then fn main, and print target detected. So the input, which is scan.rs, it outputs scan.I. Okay, so this is the original. So this is w- I don't understand what's going on, but I'll try. I'll try to understand what's going on. Hmm. So you have before processing, you have include network.h, and then after pre-processing, you have void connect socket and void send packet. And phase two, you have the compiler where input is scan.i, output is scan.s. The operation, so C of S prime, the modified source code is equal to A. Can I be honest? I didn't understand anything, but because you will make it worse, I'm forcing myself to understand. I'm forcing myself because he will make it worse. So I wrote scan start. So this is a human language. The computer CPU cannot understand this directly. The compiler will then convert this print data gets translated to low level instructions like move the data, call, print, return. You do not need to understand the assembly yet. So compiler translates the code into lower level instructions. So the machine code, eventually the instruction will become in binary format. So the CPU can understand it. Okay. Um, so was that the entire explanation? Because there's a lot that he explained here. Okay, so you made it confusing again. Made it confusing again. Uh, wait. Uh, what is going on? Come on, come on. What is going on? Like it's not difficult. Like come on. You know what? I also have to read the book. So the Hello program begins as a high-level C program because it can read and understand by human beings in that form. However, in order to run hello.c on the system, The individual C statements must be translated by other programs into a sequence of low level machine language instructions. These instructions are then packaged into a form called an executable object program and stored as binary disk file. Object programs are also referred to as executable object files. On a Unix system, the translation from source file to object file is performed. Yeah, no, these this guy cannot explain. Like, no, 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 no. Let me just delete all of it actually. Eh. So here the GCC compiler. So Linux we have GCC hello hello.c. So here the GCC compiler driver reads the source file and then translates into an executable object file hello. The translation is performed in the sequence of four phases. The program that performs the four phases are the preprocessor, compiler, assembler, and linker, and then you execute it. Makes sense. So preprocessor phase, compilation phase, assembly phase. I read it, I understood, but what did you understand? I want to see that. What did you understand? So I read it. First of all, I read it. I understood. I want to see what he understood. So I read the book. I understood. I want to see what you understood. And based on your understanding, I want you to teach me like as if I know. You know what? You have to know because they're going to use kiddish examples because they don't understand that there is a literal academic book that you're writing. They don't understand that. So the computer cannot directly run scan.c because the CPUs do not understand C language. CPU only understands the machine instruction. So the source code must be translated before the execution. So enter the pipeline. So the image will show scan.c, then scan.i, then scan.s, then scan.o, then scan. Where is the image? That's not what it shows. It shows hello.c, hello.i, hello.s, hello.o, hello. But which is scan. That's completely fine. Because he's using hello, I'm using scan. So the source program, so example, if I say target found, so and the file that they're targeting is scan.c, this is a human readable source code. And the CPU cannot execute this directly. So it's going to go from scan.c to scan.i. So the purpose is that it handles hash include, handles the macros, inserts the library definitions. So you have scan, so it goes from scan.c to scan.i. This is what you call a compilation what is it called? Preprocessor. So this is a preprocessor. It goes to a preprocessor. It converts from hello.c to hello.i. So it handles the include, it handles the macros, it inserts the library definitions. So before you have include stdio.h, and then when you after pre-processing it, it'll have that there. So it's going to convert all the letters, although each of those letters into values. Then compiler. Then it goes from scan.i to scan.s. Compiler converts the high-level code into an assembly language. So if I have x is equal to x plus 1, so it's going to do the assembly output. And then assembler scan.s to scan.o. The assembler will convert the assembly to binary machine code. So what is scan.s though? Scan.s is the assembly output, and the assembly will then be converted to a binary format. And then what is linker? Linker is scan.o to scan. So combines the user program, combines the libraries, combines the external functions into one. Okay. All right. So um what I read based on your understanding is that it reads the file, it converts the file from the source code to a modified source program. So it modifies the source program, which do you have to write it? I think you have to write it. You have to actually write it down. No, you don't have to because they do the program already. And then core idea. So that's the core idea. Um, and then it compiles it. So it compiles from a high level code, which means the code that you literally read, to an assembly language. And it transforms that assembly language into a binary machine code. So let's say, for example, add x1. So it's going to convert those to binary format. And now the CPU will understand it and it's going to linker it. So it combines the user program, it combines the libraries, it combines whatever functions is needed into that executable function. So let me correct one thing. I'm just going to snip them and then explain them. Oh no, like it is difficult. Believe me, it is difficult. Don't think this is easy just because I'm using AI. Don't. This guy cannot explain well. You have to understand it beforehand. So first, I input the code. So I write a C code. I have one question. Why are we going for C if we don't know C programming language, right? I have a question. You have to know C, right? Which means you have to know programming languages, correct? Oh, I don't know them. I don't know them. So do I have to uh stop and learn the programming languages first? I think so. Okay, we grow together. Don't worry. All right, I got it. I got it. All right, so where were we? So this is step one. So first I input the code. So I write a C code so that a human will be able to understand the code, right? So the human will be able to understand the code. All right. Who? All right. All right. Let's go back. Let's go back. Go back. When Valentina looks at my messages like, yeah, I need to work hard. 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 Oh, so we got the stage two, which is the preprocessor. It goes from the human readable to the preprocessor. So like include stdio.h. They have their own program. So yeah. So what they mean is that this itself has their own program, right? So that include stdio.h, that itself has their own program. That itself has their own program that will allow the um, pre-processing conversion to begin. Wait, shut up, man. Just finish the book, man. Yeah, just 369, one more. Uh, yeah. Can you write the entire academic book for chapter one specifically based on the abstract? Also, um, edit the front, like the book title, like make an academic book for cybersecurity. No, like how a university book will look like. Also, have a blank page, and by the time I going to finish it quickly. I know there's a YouTube channel for it where they will teach it thoroughly. I know there's a YouTube channel for it. Like you don't need this many books. Like sure, book is good, but then like you know. Oh wow, it worked. Did it work? I don't think so. I don't think it's really that good. I figured. Oh no, I have to go through that shit again. Fuck, man. I didn't. No, uh, fix it. You were the one who did it. Oh, come on. There's way too many blank pages. I don't know why. There's way too many blank pages. Like, do you know how an academic book looks? You know what? I'm just going to open one academic book. Like, it's not able to understand. Like, you have way too many blank pages. Mm. Let's use this one as an example. So you see the books. You see how the book is neatly written and stuff. You see how the book is neatly written. Like there is not many blank pages. You see, there's not many blank pages. They only have one blank page. They only had one blank page, and then the chapters begin. You see how the chapters are written? Look at the chapters here. Look, chapters and then chapters. See the way they explained it? See the way this book did it? Exactly like this. Like in terms of structure and explanation, please make it, academic, not, a kid's game. Um, do it. Like, yeah, write the latex code for it. Go do it. No, I meant, oh no, it's gonna write the latex code for quantum mechanics, I think. Man. Oh no. Yeah, it kind of ruined it. I can see it. It ruined it. I can already see it. That is really good. That is really good. That is really good. Really good. That is really good. Oh my god. That is really good. Oh my god, that is really good. That is really good. Really good. Really nice. But are we missing anything else from anything else from, or does that explain the entirety of chapter 1 based on the abstract? That is really good. That is really good. That is really good. Really, really good. Can we add those? Can we add those? Yeah, can we add those? Can we add those on the book? Like, can we modify the latex code again, this time adding whatever we missed? That is really good. Like, I like the book. It looks amazing in honor of Valentina Gomez Noriega. And I'm not going to use the book. I'm going to use that is really good. Oh my god. Oh my god. Can I say something? Oh my god. You know, I will actually understand thoroughly from my own book. That's how good it is. Man, thank you, man. Thank you. Thank you. Thank you. Oh my God.